Good morning, students. In last video we have studied polynomial, concept of polynomial, zeros of polynomial. Today we will study geometrical meaning of zeros and exercise 1 2.1. Okay, so I hope you have understood the conceptual meaning of zeros. Geometrical meaning of the zeros of a polynomial. Why are the zeros of a polynomial so important? To answer this, first we will see the geometrical representations of linear and quadratic polynomial and the geometrical meaning of their zeros. So we will see in the graph. First geometrical meaning, see, given a polynomial px of degree n, the graph of y is equal to px intersects the x-axis at most n points. Therefore, a polynomial px of degree n has at most n zeros. Means if degree of polynomial is n, then number of zeros is also n. If degree of polynomial n, then the graph of the polynomial will cut the x-axis at most n points. If the graph cuts the x-axis at 1 point only, then the number of zeros is 1. Okay. Exercise 2.1 question. The graphs of y is equal to px are given in figure 2.10 below for some polynomials px. Find the number of zeros of px in each case. First question, in this graph of px is this, a straight line, and we see that the graph does not intersect x-axis at any point, so the number of zeros is 0. It means this px has no zero. Answer of first question, the graph of px does not intersect x-axis at any point, so the number of zeros is 0. It means it has no zero. Second, see the figure of px, and we see that the graph cuts x-axis at 1 point only. It means it has 1 zero. Of px intersects x-axis at 1 point only, so the number of zeros is 1. See question number 3rd. In this question, graph of px is this. We see that graph of px cuts x-axis at, this is 1 point and 2, 3, at 3 points. So number of zeros is 3. Graph of px intersects x-axis at 3 points, so the number of zeros is 3. Okay. Fourth, in this is the graph of px. we see that graph of px cuts x-axis. This is x-axis and this is y-axis. Cuts x-axis at 1, 2, 2 points. So number of zeros is 2. The graph of px cuts x-axis at so the number of zeros is 2. Question number 5. This is the graph px and graph of px cuts x-axis at 1, 2, 3, 4 points. So number of zeros is 4. The graph of px cuts x-axis at 4 points. So the number of zeros is 4. 6 you have to solve yourself. See, this is graph of px and this is x-axis, and we see that graph of px cuts x-axis at 1, 2, 3 points. So number of zeros is 3. Yes, let us understand the concept of relationship between zeros and coefficients of a polynomial. So first we see linear polynomial. Linear polynomial ax plus b. Zero of linear polynomial is equal to, you transpose, if this is 0, transpose b to the right side minus b and upon a is equal to minus constant term and this is coefficient of x. Okay. Second, quadratic polynomial. Quadratic polynomial. Quadratic polynomial exam ax square plus bx plus c. This is a quadratic polynomial because degree of the polynomial is 2. So this is quadratic. So a, b, these are coefficient of, this is number, coefficient of x square, this is coefficient of x, and there is no letter, no variable, so this is constant. So first if zeros, it has 2 zeros. If zeros of quadratic polynomial are alpha and beta, then sum of zeros is equal to alpha plus beta is equal to minus coefficient of x upon coefficient of x square, and or alpha plus beta is equal to coefficient of x is b, so minus b, and coefficient of x square is a, so minus b upon a. Product of zeros is equal to constant term coefficient of x square alpha into beta is equal to c, and coefficient of x square is a, c upon a. Okay. Cubic polynomial. If alpha, beta, gamma are zeros of a cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma is equal to minus b upon a gamma plus gamma alpha is equal to c upon a alpha beta gamma minus d upon a. If alpha and beta are zeros of a polynomial then the polynomial is equal to x square minus alpha plus beta into x plus alpha into beta. Okay, if zeros are polynomial are given, then you can form the polynomial. Exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So let us solve this question. First, minus 2x minus 8. So first we will find zeros of this quadratic polynomial. To find zeros, factorize it. Find factors, factorize it first. So x square, split middle term, multiply first and last, you will get minus 8x square. Find two factors whose product is minus 8x square and sum is minus 2. So 4 to the 8 minus 4x plus 2x minus 8. This can be written as this. Now make group up to two terms. In first two terms, 4x, what is common? X is common. So x minus 4. In second group, plus 2 common. X minus 2, 4 is 8, 4. Again, x minus 4 common. X plus 2 in second bracket. So x minus 4 and x plus 2 are two factors of this polynomial. So we have to find zeros. If value of this is 0, then x minus 4, if x minus 4 is equal to 0, then x is equal to 4, this is 1 0. If x plus 2 is equal to 0, then x is equal to minus 2. So two zeros are alpha is equal to 4 and beta is equal to minus 2. Now sum of zeros is equal to minus coefficient of x upon coefficient of x square. Sum of zeros 4 plus minus 2 is equal to here coefficient minus coefficient of x. Coefficient of x is minus 2. Coefficient of x square. Coefficient of x square is there is no number, it means 1. So 1 is not necessary to write. So this can be written 4 plus multiply minus 2 and minus multiply minus plus 2. 4 minus 2 is equal to 2 and here 2. So this verified that sum of zeros is equal to minus coefficient of x upon coefficient of x square, or alpha plus beta is equal to minus b upon a. Product of zeros is equal to constant term upon coefficient of x square. Product of zeros 4 multiply minus 2 and coefficient constant term is minus 8 and coefficient of x square is 1. 4 2 is 8 minus 8 and this is 8. Okay, product of zeros is equal to constant term upon coefficient of x square. Okay, students, you have to solve other questions of 1. See these questions. Next day we will solve question number 2